Good morning, algebra. Today we're going to look at simplifying expressions. So not really pre-algebra, but a very kind of a basic algebra concept. A lot of times is covered in pre-algebra and previous math classes. Um, so simplifying expressions for today, our learning target, you'll be able to simplify an expression using distribution. So that's the new thing we'll look at, and also combining like terms, which is not really new because we looked at that last time. But both of those two things are going to show up today, and distribution is a new idea. So before we get started here, uh, my mouth is not feeling very fresh, so I got to grab some gum here. Mm, yeah, much better. Pardon my chewing. Okay, so here's the story. Devin is putting together Ziploc baggies of gum. It's like gift bags or something. He's going to give to his friends, and so he takes 3 packs of gum, puts it into the Ziploc bag, and 5 individual sticks go into each Ziploc. So you want to be able to have more than just the 3 packs worth. I don't know. He had a bunch of extra sticks of gum that maybe people gave him for his birthday, something like that. Anyway, so he repeats this process to make 4 Ziploc baggies. So just like in the picture here, I got a Ziploc bag, 3 packs plus one, two, three, four, 5 individual sticks. Repeat, repeat, repeat. Okay, write an expression to model this situation. So we've got pictures here. Here's the algebra expression. Okay, just for clarification today, you will not have to write any of these expressions yourself. There are no story problems. I just want to use this as an example. So in math, one of the things that shows up are a lot of times we have the trouble understanding what the heck it is doing are these parentheses, right? Set of parentheses is just a way of grouping numbers together, right? And just like this Ziploc bag is a way of grouping things together. Do we have to use a Ziploc bag to group packs of gum together? No, but it makes a great example that is very tangible. We can say, hey, these parentheses are just a way of grouping this stuff together. Okay, group, group. Everything inside those parentheses is the stuff that goes inside the Ziploc bag. Okay, so in this case, Devin made 4 Ziploc bags, and so I'm going to take those Ziploc bags right there. I'm going to multiply it times 4 because there's 4 of them. All right, well, how do I do that? Well, let's think about it. So each one of these packs of gums got 4. There's 4 sets of these, but each Ziploc has 3 packs in it. So altogether, I'm going to take these 3 packs and multiply it by 4 because inside each of those Ziplocs, there's 3 packs. So I'm going to have to multiply this 4 times those 3 packs because there's 3 packs in each Ziploc bag. Okay. Similarly, in each of the Ziploc bags, there are 5 sticks of gum. 5 here, 5 here, 5 here, 5 here. So I'm going to take these 5 sticks and multiply it 4 times to get the total amount. So I'm going to have to take this 4 and multiply it by that 5. Okay, so this is what distribution means. Distribution, if we just think about that word, basically means like a way of like passing things out. Like if we were in a classroom together and I had a worksheet and I was going to distribute it to everybody, I would give one to each person in the class, right? The class is like the group, and I give one piece of paper to each person. It would have been the same thing with this multiplication by 4. We're going to take that multiplication by 4 and like pass it out to every single student inside the classroom, right? Each of those terms inside the parentheses gets multiplied by 4. Okay, so enough talk. Let's do it. So I'm going to take the 4 and multiply it times 3x. That'll be 12x plus. So I'm going to bring that plus sign down here. And then 4 multiplied by that 5, that's 20. Okay, all together, how many packs of gum does Devin have in all of those Ziploc bags? Well, he's got 12 packs plus 20 more sticks. Now everybody's got nice fresh breath and we feel very happy. Yay. Okay, so you ever do this? I don't know. Sometimes people like to try to play tricks on one another. Right? We take a pack, open up a pack of gum, take out a stick, open up, unwrap that stick of gum, and you can pull the piece of gum out. And if you're careful, you can still see where all those creases are. you're gonna wrap the wrapper back up, but there's actually nothing in there. It usually doesn't work when I do it. People are like, "Dude, there's no gum in there. Like, it's an empty wrapper." Well, we try anyways, right? Okay, so Leora was doing that. Leora wanted to play a joke on her brother, so she removed some of the sticks of gum out of the wrappers and just put back the empty wrappers, very carefully refolded. So I'm going to represent those with these red wrappers, um, just for visual effect, so we can see the difference in our example. The red wrappers, those are empty. So I'm going to count those as negative because there's not actually any gum in there, right? So in math, you can think of a negative sign as like opposite, right? And so this is like the opposite of having a piece of gum is not there, right? We don't actually have it. So Leora starts out with 8 packs of gum. Boop, 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 boop. There's 8 packs right there. She takes 2 of those packs to put into a Ziploc bag. She's gonna make a little Ziploc gift bag to give to her brother. So there's 2 packs in there. But out of those 2 packs, she carefully removes 5 sticks. Takes the gum out of the wrappers, folds the wrappers back up, puts the wrappers back in the pack. Okay, I mean, if we just left them in a Ziploc bag as empty wrappers like this, that's not going to work. So it's just for illustration purposes only, right? Those carefully rewrapped empty wrappers go back into the pack, but all of that is in this little gift bag here. Okay. Um, After she gets done with the trick, then she finds another pack of gum in her pocket, and so she adds that to her collection. I'm going to write an expression to model this, and again, you don't have to do anything with story problems. Your job will just be to simplify the expressions. So here's a different kind of story. This one involves taking things away, right? So I started off with 8 pack, or Leora started with 8 packs. We took away from those 8 packs, we took away this group, right? The Ziploc bag is like these parentheses. Inside that Ziploc baggie, there were 2 packs, so that's going to be 2x. And then the empty wrappers, those count minus, right? So the empty wrappers is going to be -5 because from the 2 full packs, it's not actually 2 full packs of gum anymore. We took away those 5 sticks and just put back the empty wrappers. Okay, and then after all of that, the Ziploc bag is done. We close the parentheses then, plus the 1 more pack of gum that we found in the pocket. Okay, so we got some minuses showing up in a couple of different places. This one inside the parentheses is representing the fact that we took away those sticks of gum. It's just an empty wrapper. This minus is representing what we took out of the 8 packs of gum to put into the Ziploc bag, right? So we took away that Ziploc bag, gave it to someone else, it's gone, right? So that's like it's taking away. It's the subtraction. Okay, so whether you like the story, you don't like the story, it's just here as an illustration. So here's what's happening. I have an algebra expression that has some parentheses in it, and those parentheses are being subtracted, right? So I can distribute subtraction, just like the previous example we saw, we distributed multiplication. So I'm going to take this minus sign, and it is going to get distributed onto all of the elements, all the terms that are inside those parentheses. So I'm going to have to put the minus onto the 2x because I took away those 2 packs of gum. I'm going to have to take that minus and distribute it onto the -5, right? And the plus x over here, that's not inside the parentheses, so that does not get affected at all by this minus sign. The minus sign is only being distributed into the things inside those parentheses. Okay, so let's rewrite our next step. 8x, nothing happened to that, so I'm just going to carry that down to show my work. And then let's do the red arrow first. So I took this minus sign and I distributed the minus onto the 2x. So this is now going to be minus 2x, or negative 2x, whatever you want to say. It will make more sense for a number sentence to call it minus 8x minus 2x. And then, okay, great. Sorry about that. The minus sign is going to get distributed onto the -5. So if you have a minus here in the pink highlight, and then we distribute that onto a negative number, it's like subtracting a negative, the double negative. I'm going to basically make it like a plus. So I'm in blue still. This is going to be like a +5. Okay, and don't worry about if the gum analogy falls apart. Okay, let's not worry about the gum. The minus sign distributes onto another minus sign, two negatives, make it positive. It's just a plus 5. You could say that, those sticks of gum that Leora took out of the wrappers and put the wrappers back, she kept the sticks of gum. And so even though it looks like she took away the 5 sticks, she actually got to keep them for herself. And so that's why it's a plus. If that works for your explanation and your understanding, then let's go with that. And then at the end of the expression, I got this plus x that was not affected by the distribution that we did. And so I'm just going to bring it down to my next line so I keep track of it. It's still there. Still got to do something with it. Okay, so that was the distribution part. I still need to combine like terms. So in this expression, I've got 8 x's. I took away 2 x's, and then over here, I've got another x. There's not a number on that, but it represents the 1 pack. Anytime we got a variable with no number, if there's no number, it means 1. We just often don't write 1 because save ourselves some time by not writing down extra stuff. So I'm going to highlight all the x terms. I want to collect the things that have like terms. So here's one, and here's one. And remember, when we combine like terms, we have to keep the sign, which is directly to the left of that variable and coefficient, together with it. So this will be 8x minus 2x plus 1 more x. And just for the sake of clarity, I can write a 1 in there. So let's go from left to right. 8 minus 2, that's going to be 6, plus 1 more is going to make 7 x's. And then I'm going to look at the other terms that are left. I only have the one constant. That plus 5 right there is the only constant that's in here. So it's not going to change. There's nothing to combine it with. It's going to be a plus 5. And we can circle our final answer. Yay! All right, so I'm going to show you a couple more examples, but without those silly gum stories. So I've got set up to illustrate here with algebra tiles, and I think I'm going to save the algebra tiles for later. It's just a different way of modeling things to help us understand, but in this case, let's not demonstrate with the pictures. Let's just look at this expression. Let me turn back to my pen. Okay, so I got 7x minus 3 and then parentheses 2x minus 12. This 3 and the minus sign need to be kept together. That's what's being distributed. So I'm going to go back and forth in the way I described that minus sign. Sometimes I'm going to call it a negative. Sometimes I'm going to call it a minus. There is not actually a difference. It's just what we think when we say the word. We start thinking things differently. It's not actually a different meaning, whether you call it a minus or whether you call it a negative, actually are the same. But we do definitely say different things sometimes. Okay, well, so the -3 is what's going to be distributed. So I'm gonna, in this case, there's the 3 is right up next to the parentheses. That means multiplication. If the 3 and that minus sign that are inside the circle here, if they were switched around, so it said 3 and then minus, and the minus was right next to the parenthesis, then I would only be distributing the minus sign like we did in the previous problem, or 2 problems ago, whatever it was. Okay, but if the 3 is what's touching the parenthesis, then this means multiplication. So a lot of times for multiplication, we don't actually put a symbol there for it, but if there's a number and a letter right next to one another, that means multiplication, like the 7 and the x that's actually being multiplied, 7 times x, or like the 3 and the parenthesis. They're right next to each other and touching, it means multiplication. Okay, so here goes. We're going to multiply this -3 onto all the elements, so those terms that are inside the parentheses. So I'm going to multiply it onto the 2x. Also have to multiply it onto this -12. Okay, I'm going to write down all of my terms from left to right. The 7x, nothing happened to that, but I still got to bring it down. That's part of my problem. And then we'll go with green next. So the negative has to stay attached to that 3. So -3 multiplied by 2x is going to be -6x. Right? So I just said -6 out loud because that was the multiplication. A -3 times a +2 gives me a negative answer. But when I'm reading this number sentence in a minute, I'm going to say 7x minus 6x because when I'm combining like terms, I'm going to want to subtract that. Right? Negative and minus really no difference. Just different words, but it means the same thing. Okay, last step. Following the blue arrow, I'm going to take this -3. I'm going to multiply it by this -12. So we can't lose the minus sign. That's going to be attached to the 12 because it's directly to the left of the 12. And we always keep the sign that is to the left with the number, whether it's a coefficient or a constant, either way, it doesn't matter. So negative 3 multiplied by negative 12. So 2 negative signs in this multiplication problem, which means you're going to have a positive answer. And 3 times 12 is 36. Okay, I've done the distribution. Now let's combine like terms. So I have some x's, 7x minus 6x. Those are like terms. They're both x's. I'm going to combine them in this case by subtracting. So 7 minus 6 is going to be 1x. I can write the 1 if I want. I don't have to. I do definitely need the x, but I could just write x, or I could put 1x. Either way is fine. Typically, we don't write 1s as coefficients because they're extra writing and they're not needed. And then I've got the plus 36. Okay, let's circle this one in flowers. Yay! Okay, one more example. So the last thing that we can distribute is division. And so you're going to look at this problem. I'm going to get rid of the algebra tiles. We're not going to use those to model this problem. So you're going to look at this and you're saying, well, that looks like a giant, big, ugly fraction that's got like algebra inside of it. Oh, man. It's not actually that bad. It looks scary. It's not actually bad. So we use this line for division, for fractions, which really are just different words that we apply based on the situation, but they mean the same thing. A fraction is a little division problem. Any division problem you can think of as a fraction. Okay, so here's what I need to do. I need to take everything that is on the top of the division problem, the 8x minus 24, both parts, the 8x and the minus 24, are going to have to be divided by 4. Okay, so there are not parentheses here. Parentheses are just a symbol that we use for grouping things together, right? Like a Ziploc bag and the packs of gum. So sometimes there are other ways that we can write things in a number sentence, an algebra expression that also mean grouping. Okay, so the 8x minus 24, those are all grouped together as as part of a division problem, right? So I need to take each of the separate terms and divide each term by 4. So I'll have to do 8x divided by 4 and minus 24, or I'll probably call it negative 24, also needs to be divided by 4. The plus 7 is not part of this division problem, so if it's going to stay as a plus 7, I'll deal with that in just a minute. So first of all, 8x divided by 4, that is 2. I'm going to keep the x on there because the x doesn't change. I had 8 x's, 8 packs of gum. I split it up between 4 friends. Each person gets 2 packs. All right. And then I got negative 24 divided by 4. If I think about how many negative signs are in this problem, there's just the one negative sign. And so that means I can have a negative answer. So I'm going to put a negative sign here. 24 divided by 4 is 6. All right. And now that I've just said that's a negative 6, but when I read the whole number sentence in a second, I'm actually going to call it a minus again. Okay, so that plus 7 here at the end, we can't forget about that. It's got to come down. Still part of the problem. So I've got 2x minus 6 plus 7 combined like terms. In this case, I've got constants in 2 spots. I got the negative 6 or the minus 6 and the plus 7. I'm going to put those together. So that 2x is not going to change. So I'm going to bring that down as part of my answer. And then negative 6 plus 7, that's going to be positive 1. All right. Final answer. So there's all the different ways we can distribute. We can distribute a negative sign or subtraction. We can distribute multiplication. We can distribute negative numbers. We can distribute division. Awesome. All right. Good luck and enjoy some nice refreshing gum and math.